some safety goggles on. And can I get you to put on the ridiculously large insulated rubber gloves? Awesome. All right, Carson, I'm going to leave that there just for a second. Can you hold on to this end of the really stretchy rubber tube? And just a reminder for anybody just joining us, please stay outside of the red danger area. Outside of the red danger area. Thank you. All right, Carson, hold on to your side tight, 2 hands. Really, really tight. Do not let go whatever you do. Otherwise, it's going to snap away from your hands and up towards my head. I don't want that to happen. Okay, no welts. Okay, I'm going to hold on really tight to my side. What we're going to do, we're going to try and stretch out this tube as far as we can, okay? Ready? 1, 2, 3, stretch. All right, so this is a pretty stretchy rubber tube, and it can even work like a guitar string. Carson, play the string. Strum. Boing, 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 boing. All right, so very, very stretchy stuff. What we're going to do, we're going to see what happens when you take the molecules in here that have those elastic properties and they're able to slide past other molecules and change the shape of this tube. We're going to see what happens when they lose their heat energy. So we're just going to drop that right in there. Now, while we're waiting, Carson, how's it going over there? Good. All right, Carson, we're going to give you a job. We're going to run a second experiment as well, okay? What I have here is a rubber ball, okay? This is the control ball. This is the one that we're not going to do anything, okay? So what I need you to do, I need you to hold on to the ball, okay? You're going to hold that up about shoulder height. And on the count of 3, I would like you to drop that on the stage, and we're going to see what happens to the control ball that has not had anything weird happen to it, okay? Are you ready? 1, 2, 3, drop it. It bounces. Okay, so a normal rubber ball hits the ground and bounces back up. Everybody agrees? Everybody saw that? Everybody's good with that? Okay. Remember that, because we're going to go back to that in just a moment. But first, we need to go back to our rubber tube. Carson, just put the rubber ball right back there. Back to the rubber tube. Okay, we have taken away the heat energy from the molecules in the rubber tube. Carson, I'm going to get you to hold on to that end. Really tight, don't let go. I'm going to hold on to this end. And on the count of 3, we're going to stretch it out. Ready? 1, 2, 3, stretch! You're not pulling hard enough. Pull harder! No, that's a lot frozen. Remember, minus 180 degrees Celsius. Okay, so we are not able to stretch this out of that frozen shape, that frozen sort of horseshoe shape. Or omega, but no, whatever. The reason for that is we've taken away the heat energy from those molecules. So remember, it was at normal temperature out here when we started. We were able to stretch it out like a guitar string. But then when we put it in the minus 180 degrees Celsius liquid nitrogen, it got cold. It lost a lot of heat energy. And that's why our liquid nitrogen is still kind of boiling, because it's heating up and stealing heat energy from everything around it. So because of that, those molecules can't slide past each other anymore, they can't change their shape, and they get frozen. They literally get stuck in place. Okay, so we can try pulling that, we can try breaking it, but we may actually shatter the rubber tubing. Instead, what we're going to do, the smarter thing, we're just going to take the rubber tube, we're going to leave that on the table here, we're going to go on with the rest of the show, and at the end of the show, I'll pick that up and I'll try and stretch it out, and it should have warmed up enough, and it should be fine. Carson, grab the control ball again. All right, so earlier in the show, we had Carson drop a control ball on the stage. We saw what happened to it when there's nothing happening to a rubber ball. Go ahead. 1, 2, 3, drop. A normal rubber ball bounces. However, if you take a rubber ball and drop it into liquid nitrogen and leave it there for a couple minutes with some other demos, then you take that out, and it gets really, really cold because it's lost its heat energy. Watch what happens. Carson, drop that on the count of 3. 1, 2, 3, drop it! Drop the control ball. Control ball bounces, drop the frozen ball. Take the control ball. Here. 1, 2, 3. All right, so when elastic stuff, bouncing balls, stretchy rubber tubes, when they lose their heat energy, they also lose their ability to stretch and change their shape and go back to their shape and bounce and do things like that. Let's give Carson a very big hand for helping us out. Thank you very much, Carson.
Good job, Booger.
Good job. I like the apocalyptic touch too. That's kind of a nice touch. Okay. Did you try and kiss that? Okay, good. Because you don't want to. Your lips would freeze. Have you ever seen A Christmas Story? You're laughing because you have. Okay. All right. Back to our liquid nitrogen. So we see what happens when you put objects that have elastic